All right. Well, let's get into our next big topic in the course. And that's all about data, data management, and that sort of thing. And we're going to start by looking at databases, just explore them in a little more depth. You may have already done this in other courses, or you may not have. And so depending on your experience up until now, you may have a little more work, a little less work to do this week, but let's take a look. Our learning objectives for this portion is to go through and understand what content is and how we might organize that, talk about what a database is and what's in there, and then something slightly different, a database management system, DBMS. How's that different? What does that do? And again, here's something slightly different, a database application. What's that all about? And then finally, we'll look at the difference between different types of database packages out there that you might be able to work with and kind of where we're going technology-wise. So let's get going. What is content? I hear that word a lot, content creators, for example, content management, that sort of thing. But do we really have a sense of what it is? Well, content is information. Would that be maybe one good way to describe it? Sure, I think so. Property. Maybe that's another way to think about it. Could be property, something we own. If we think about organizations, we often say we have some intellectual property or some value, right, to the data that we have or the information we have. So maybe I should call that intellectual property instead. Maybe that might be another term for that we see a lot. Essentially, though, content is, maybe nicely viewed as just things that we create. So that might be intellectual property, it might be information, things that we create that are valuable that we want to store. All right, that's content. Well, and how do we store that? Well, traditionally, we've stored that in a paper format. Right? And so think about the bulletin boards that you might go by. They might have news on them or notices or events. Maybe they've got advertisements for jobs or something for sale, or somebody's looking for something, a wanted ad. Maybe they've even got some policies. If you think about any of the classrooms you may have been in, often there's some policies up there. Maybe there's a map. How do I get to the washrooms from here? Something like that. All kinds of things could be on those bulletin boards. Well, that's really content, isn't it? Absolutely. Now, in our course, though, we're more technology focused, so we might see similar type of content, but not posted on a physical bulletin board, but maybe posted on a web page. This is the main page for Camosun College, and it's got news, course information, it's got events and special dates, procedures, job postings, policies, maps, much the same type of information that we had on our physical bulletin board is now available on a web page. Well, how does it get to that web page? Where does it come from in the first place? It must be served up from somewhere. There must be some sort of web server connecting to a database to bring that information out to us. All right, so that sort of sets the stage, I guess, a little bit. So content management is all about managing our data. All right, so we're going to manage our data. We want to do that efficiently, right? So we can quickly get information in and out, and we don't waste resources and all that good stuff. And we want to be effective, making sure that we're doing the right thing all the time as well when we're processing our data. Now, I mentioned a minute ago, database management systems, they're the bigger all-encompassing package that we have that helps manage our databases, all right? And not just when we're using them, but also when we're creating them and maintaining them and things like that as well. We'll get to that eventually. Content management also includes presenting that content. All right, so we might have a content management system, helps us present that. Think about the web pages you go to. Many of them present content from all over the place. Let's go to Expedia, for example. That's pulling in content from airlines, from hotels, from car rental agencies, from all over the place, and putting it all together in microseconds for you to view. That's a pretty impressive task if you think about it. What's the content management look like for a website like that? Right? Probably pretty interesting. So there's lots going on there. So our challenge is processing and storing the right content. Right? So we want to make sure we've got what we need to get our jobs done, and getting that content out to the right people in the right format in the right time. So sort of three elements there. It's got to be timely, it's got to be correct, and it's got to be effective in that it goes to the right person. All right. It doesn't do me any good to get a report that about grades long after the class is over. I have to have that right away. And for example, if I had information coming in that there was someone on the wait list moving into the class, probably better I get that right away at the beginning of the term so I can help that student out before too much time goes by. All right, so we want to get the right content to the right people in the right format at the right time. Well, databases are a big part of that, as you might imagine. And let's have a look at what they are. A database helps us keep track of things, essentially. That's all it does. You may have done some database work in Biz 145, if you've taken that course. And you may even remember a little bit of it. Maybe not, but we'll see. We don't have to use databases, though. You may have used spreadsheets before to keep track of simple things, right? So maybe a list of students with their grades, that might look something like this. Here's an old list from a few years ago. We got uh, student number, their last name, their first name, and the grade they got. All right. And I've got a whole list of them. That's sufficient, isn't it? I can go in there and I can sort it by grade. I can sort it by last name. I could even sort it by first name, which is how I often remember people when I think of them. And so I could do some neat things with that, and it would be useful. All right, so that's not bad. And that's just in Excel. I don't need to learn Access to do that. The trouble is, when I get into storing multiple things, it can get a little bit crazy. So here's a similar spreadsheet, but this one is for not just Biz 141 or Finance 110, but for all my classes. All right. And so we'll see Bill Smith in there at the top is in there 4 times. Apparently Bill took 4 classes. Did pretty well overall in them too. If we look over the far right to see his grades. And then if we go down, we can see that Susan Jones took 3 classes, did okay in them. Well, maybe struggled a little bit there. Oh, it actually took 4, sorry. I said 3. Ted came along, took 4. Jim only took 2, did really well in them though. Jane took 2 and did well in hers as well. And we could just go on, right? We can see there's lots of classes on the go there and lots of students. Can you see any problems with this spreadsheet? It does work, doesn't it? But I'm duplicating information over and over again. I put in Bill Smith's name 4 times. What if I typed it wrong? Put him in as William 1 time. Would I know that's the same person or not? Maybe with student numbers I could be okay, although I'm duplicating those a lot too. But what about the courses? What if I typed that in differently 1 time? So instead of business communications, I put in business communication by mistake. Could I then go and search and say, show me all the students in business communications? Well, see, we get a bit of a problem. I'm retyping. I'm not being very efficient, am I? I'm duplicating over and over again, and I've now introduced the potential for mistakes. When we get into tracking more complicated things like this, sort of multiple dimensions to it, that's when we find that databases can be more helpful. All right, so databases keep track of multiple things and allow us to connect this information or set up relationships, really. That's what those connections are, cross references, so that we can work with it in lots of different ways. So I can keep track of students and courses separately and then connect them with my database. Maybe I can keep track of fee payments. Maybe I can keep track of grades over time. What if someone took a class twice? First time through, they got a D because things weren't going so well for them that term. So they had to take it again and they got an A. Well, I probably want to keep track of both those cases, don't I? So I could do that with the database without too much trouble, and I could put it all together to work with it. So databases allow us to work with information that's just a little too cumbersome, too complex for Excel to handle smoothly. All right. Now keep this in mind. This is interesting too. Over time, we've noticed that spreadsheet functionality is getting better and has more data features than ever before. At the same time, database technology is adding in more spreadsheet functionality for doing, kind of interesting calculations and data analysis. So spreadsheets are getting better, especially at data analysis, but also at managing data. And databases are getting more like spreadsheets in a little bit. There's still lots of difference between them, though, even though there is a little bit of overlap. All right. So what's in a database? Well, I guess the classic description of a database is it's a self-describing collection of integrated records. That sounds interesting. What's a self-describing mean? Well, within the database, it actually has a definition of what everything means. All right. So it says, look, I'm going to keep track of names, and those are 20 characters long, and they can't be left blank. I'm going to keep track of phone numbers. Those follow a certain format, and they can't be left blank either. That sort of thing. It's got integrated records, and that just means we've got a lot of records on things that we're storing or data that we're storing, perhaps on students, and they're integrated and connected to let us make sense of them. So we can connect them to classes, for example, and that kind of thing. So that's what a database is all about, right? Now there's a hierarchy of data elements that's worth learning, and the smallest is, well, the smallest is a bit, but then we go up from there, we get into a byte. That's a collection of bits that represents one character of data, like the letter R. If I group a bunch of bytes together, then I get a field. This would be maybe a first name field, for example. Call it a column as well. If we group a whole pile of those columns together, then we end up with a row or a record. So a record would be all of the information about me, my first name, my last name, my phone number, etc. And then if I group a whole pile of those rows or records together, I'm going to get a table. That may be a table listing all the instructors. We call that a table or a file. So we start from small and we go to big, right? Here's another way to look at that. We've got in here, well, down at the bottom, you see we've got characters. We call those bytes. Here's one, the letter Y. Here's another one, the number 9. And we could circle anything in there. They're all individual elements, aren't they? Individual characters. If I group a bunch of those together, that's when I get a column, right? So I put a whole pile of numbers together and I end up with the student number. All right. If I put a whole pile of student numbers together into one file, right? Well, actually, before I do that, if I have a student number and a name and some grades, that's called a record. And if I put a whole bunch of those together, we call that a table or a file. All right, so that's another sort of visual way to look at that. Here's a third way they show us in the book we can think about it. We start with small bytes or characters at the bottom. We group those together and they become fields. So we have student number, student name, scores on homework, that kind of thing. If we group those together, we get a record or a row in our table where we have all the data about the student in there. And if we group a whole pile of students together, then we have a table or a file. All right, so we work from bottom to top there, from smaller to bigger. All right. Let's talk about a database itself and what are the pieces in there. May not have thought about this a whole lot, but there's sort of three main things that are part of a database. Okay, so it's a collection of tables or files, so just like we talked about. Maybe I've got all my student information in one table. And I have all my instructor information in another table. And I may have many other things, course information and that kind of thing. So I can have a bunch of tables. So I got a collection of those in my database. I have the relationships among those. So are students somehow related to instructors? Maybe. So I'll have a connection between those. Maybe that connection actually exists through courses. So students take a course that instructors teach. That's fine. And then I've got something called metadata. That's that self-describing piece. Metadata is data about your data. So it might say something like the postal code field has to be in the format of 3 and then 3 more, and it has to be a letter followed by a number followed by a letter, etc. Right? Number, letter, number. And so I may describe various things about that to help validate or keep the data from being corrupt. That would be metadata. We tend to do that in something called the data dictionary. And we'll learn all about these things when we get to database design in our next video. But for now, those are sort of the basics. All right. So there's 3 things within our database. Let's just talk briefly about those relationships a little more. Here's a student file or table and a grade file or table. All right. So in the student file, we see we've got Joe Smith and where Joe lives and how to reach them by telephone. So that's fine. And the student number. In the grade file, you see what course it is, the term, who taught it, what the grade was, and any notes about the person. But we're missing something. Do we know who that grade is for? Well, we don't, do we? And we don't want to end up, typing in Joe Smith and, everything about Joe over and over again for all their grades. A better way might just be to put in the student number. I'll write it at the top here. So the student number. Over here, that was kind of the key field that was unique, because I could have lots of Joes, but I'll only have one student with this student number. Over here, it's sort of a field that I'm reusing from somewhere else, so it's called a foreign key. We'll learn about that, but for now, let's just say we could actually move that into there, couldn't we? And now I know which student that grade is for. All right, so I could say student number, and I could say C012345 6. Now I know which student it is because they're connected. A relationship there that I've drawn in red is just like a cross-reference. I don't actually have to put Joe's name in there or address because I could just follow along and go backwards through this connection and see all of Joe's information. All right, so that's sort of how relationships work. All right, so we have a key field that we use as a cross-reference, or in our terminology, a relationship to hook 2 databases together. All right. What about that metadata? We said databases are self-describing, right? So they've got their own description of their contents built in. That's data that describes the data, and that ultimately makes things a lot more useful in a spreadsheet. All right, makes databases easier to use because I might say that you can't have the postal code, that it can't be blank. So I have to have a value in there. What's the advantage of saying that? Well, now I know that I'm not going to end up with missing data or data that's not very useful to work with. All right. Same thing I may say for another field. Oh boy, what would be another field we might store about a student? Well, maybe we'll store their phone number. So we'll have the phone number again, not blank. Maybe I would even say for the phone number, it should follow this format. Oops, I ran off. So one more digit there. Um, so that it all fits the correct format. I have to be careful. What if I have an international student with a different format phone number? Like where my family's from, Denmark, we use 8 digits. So um, it may not fit so well, would it? So we have to think about that when we do our design. But whatever information we decide represents or helps clarify what we're storing, that's going to be called metadata, and that's going to make our database more useful and easier to use. All right. All of these things we'll get into in much more detail when we get to the database design module. All right. So here's an example from Access. So just in case you've taken Access before, see here we are. We're looking up here at this field, the date field. All right. It says it's a date type. All right. It's the date the message is recorded into the database. That's what it says over here. Then down below, it's got more information about it. It's something called the short date. There's a format for it. The default value is now, so there's going to be a value in there. It is required, so we can't leave it blank. And there's more things there that we maybe don't care to understand or learn about, and that's fine. If I were to go and click in Access down here on student number, the bottom area would change to match. So that's how Access does it. It gives us a whole area for each and every field to go in there and tell us anything special about that field. That's metadata. All right. So if you took 145, you may recall that now, right? I hope you do. That's what that is. Okay. Well, what's a database management system then? And what does it do? Well, it has the database in there. It's sort of connected to it. So that's in the photo or in the picture here. But the DBMS is sort of sitting here beside it, isn't it? Right? That's our database management system. It's another element. We also have applications. I said we'd talk about what those are too. And of course we have the users. They're all part of the system, but they're different parts, aren't they? All right. So let's focus in now on database management systems. It's the program or the software that lets us create our databases in the first place. It also lets us process them and administer them as we use them. All right, and then do things like maintain and clean them as well. Think about the equivalent paper system. Well, the database would be the file room. All right, the database management system would be the file clerk who you went and talked to when you wanted a file from the file room. They manage things. They maybe set it up and organized it in the first place and all that sort of thing. They're kind of the interface, aren't they? Or the in-between between you and the paper files you want to get to. Well, our database management system electronically is much the same role. It's the system or the gatekeeper between the programs that want to use the data and the data itself. Now, we usually buy these from big vendors or rent them. Microsoft has several products. Oracle has some, IBM, lots of different options out there. Some of them are big systems like DB2. Others are quite small like Microsoft Access. Right? And we've worked with that. Oracle, of course, has lots. That's really what they do. SQL is another big one, right? It's not in this list. So there's lots out there. All right. So keep in mind, the database management system is like the manager. It's not where the data is stored. The data is stored in the database itself. All right, so they're two different things. What about an application then? That was also on my little diagram. That's all the forms, reports, queries, and everything else that we kind of use as users when we go into the database. All right. Now, databases can have more than one application. I can have all my employee data in a company. There can be an application that people in the HR department use and another application that people in the accounting department use that connects to that employee data. All right. Now, each application may have certain restrictions on it that's different from other applications because HR needs certain data and accounting needs other data. So that's okay. We could do that as well. And then each application can have many users. There could be several HR workers looking at the employee data at any given time. Right? So that's what applications are all about. Now, in a product like Microsoft Access, they're often combined, aren't they? The database management system, and the application are sort of combined into one little package because it's meant for smaller applications. All right. As we move into bigger products, you'll see those things get split out typically. All right, so here we go. We've got an inventory database in our organization. We have a database management system here, sort of acting as the gateway, right? So a user can't directly go in and modify and play with that data. That would be a big no-no, wouldn't it? We don't want that. They have to first go through an application. That application goes to the database management system, which then goes to the database, brings data back, goes back to the application, and back out to the user again. All right. And in this case, we've got 3 different applications or programs or apps running: order entry, purchasing, and warehouse management. All have different functions. They all might see different parts of the database. They might all have different rights to what they can see and what they can modify, and that's okay. The database management system will manage all that for us and make sure that's maintained. And it'll make sure there's no sort of collisions where 2 people try to, change the same record at the same time, for example, things like that. And it'll keep everything running smoothly. All right. So that's how it's typically split out as we get into the bigger packages. All right. I mentioned forms, reports, and queries. They're often part of this application side, aren't they? Over here, the database applications. If you took Biz 145, you might recall what they are. If not, let's have a quick look, explain what those terms mean. A form, that's something where we, it's a screen maybe that we use to read, insert, modify, delete data. It's what we use to change our data, right, or to look at it. Think of a paper form. It's exactly the same thing, just electronically. We use those all the time, don't we? Anytime you go to buy a product, you have to enter your credit card information and your name and address. That's a data entry form. What about when you go to Facebook? Sure, you're putting things in there. You're doing a status update, maybe adding a photo. That's a data entry form, right? So there's all kinds of forms that we see all the time. We don't even think about or think that they're forms, but they are. So that's for getting data in, right, and working with that data in our database. Reports, that takes the data sort of back out and shows it in a structured format. So maybe I've got a report that I generate every week that shows me attendance for my class. All right. Or maybe another one that shows me the grades so far for students. Well, I do that regularly, so it makes sense that that's just a built-in report in D2L that I can just click on rather than having to download and play with the data. All right. So that would be a report. Think of something that's printed. Right. So printed report, exactly the same thing. All right. Maybe a list of customer data. By the way, if we think about Facebook again, I mentioned that a minute ago. Report there would just be your news feed, right? That's sort of, it generates that for you, showing you what's going on. All right, so that might be one example. A query, similar idea, that's getting data as well, but it's letting you play with it in sort of an ad hoc fashion. So maybe I want to go into my data and do some exploring. I don't have any pre-written reports on that, so I just want to play around. If I have a query system that lets me do that and create a report on the fly, that's what queries are all about. All right. So it's a way to go in and ask questions. Query is just another word for question, isn't it? So asking questions that aren't routine, right? So reports are kind of more routine questions. And these are the ad hoc. Ad hoc means sort of one-off, right? The ad hoc questions. All right. So that's a difference between those. And you would have done some of those if you did Biz 145. You would have built a little database, and you probably would have made a form for entering new data or changing some of the existing data. You would have created some reports. and you may have done some grouping and sorting and things on those, and that's fine. Maybe even adding up some subtotals, computing some things. And then you would have written some queries as well, where you go in and do some less routine things where you want to go in and maybe see how many uh, room rentals did we make this past week, right? That kind of thing. All right. So that's what those three are all about. The database application programs, well, they take it a step further. So if we think about something like Facebook or using Expedia or something like that, they don't look like Access where you have a group of forms and a group of reports, things like that. It's not that cumbersome or clunky looking, is it? It's all nicely put together into something that looks like a seamless interface, and you just dive in and work with it, and you're not even really aware of the concept of forms, reports, and that sort of thing. So the application programs, they've got all the logic and everything we need to tie it together into one nice to use package. All right. They put everything together. What about multi-user processing? Now we have two people using the database at once. Let's say you and I are both working on a database, and we decide to change Joe Smith's name to Joseph Smith. Right? And so I go change it to Joseph Smith, and at the same time, you change it to Joseph Smith, but also change his phone number. And we both hit enter or save. Which one is going to get saved? Well, that's a problem that traditionally has sort of plagued us in the past with older systems. And one of the first things we had to learn was to have the database management system deal with data conflicts. All right. That's actually pretty seamless now. And we don't usually have that problem anymore. So these things like these lost updates, right? So what we'll do is we'll lock the records so that if I'm working on one, it gets locked, and you try to work on it, it says you can't work on it right now. All right. That sort of thing. It's kind of like if you're working on a Word document and then you try to, and it's open, and then you try to delete it from your hard drive, you're going to get an error message saying you can't delete it. It's in use right now. It's been locked essentially, right? So you can't do that. Same thing with our data. All right. So this is an older problem that they mention in the book, but we don't really think about it anymore. A couple more things to show you from this chapter. This is a diagram they give us showing maybe a more current or up-to-date version of a database and a database management system in operation there over on the right. They're being accessed by different application programs that are running on a web server. Why are they running there? Well, because all of the users over here are accessing through the internet using web browsers. That's much more common these days, isn't it? We'll use web browsers to access things. Think about Facebook, for example. Almost all of the users are not located at Facebook headquarters. We're accessing it from the internet. All right. So we now have web servers helping out. The application programs are hosted on those, and they're written so they can display HTML and put up a user interface that way. All right. So that's maybe a more modern look at this. They also mentioned two different types of databases. Enterprise databases, those are the bigger ones that I mentioned earlier, where we do tend to separate things out. They're great at supporting lots of data, right? Millions and millions or billions of records, supporting lots of users. How many people use Facebook at any given point, right? YouTube, by the way, is another database application. Instead of serving up text, it serves up videos, doesn't it? How many people are accessing YouTube at any given time? They need big database applications to make that work. In Biz 145, if you took that, we used what's called a personal database management system, smaller, simpler system, Microsoft Access or other ones like that, DBase, FoxPro, Paradox, RBase, all those types of systems that are common in smaller environments, and they support typically a handful of users, right? Now, Access is getting more robust over time. It can handle slightly bigger databases than it used to, and it's adding in new features all the time, but it's still considered to be kind of a personal database management system on the smaller end. I probably wouldn't use Access to program the entire payroll system for the government. It's just not strong enough or robust enough to do that. I need an enterprise database management system that can handle large amounts of data and let people from different work groups around the organization all connect and work together and do all that kind of good stuff. So where are we going next? Well, I think in terms of database technology, we're seeing a couple things. People now want to store more than just text data. They want to do images, audio, all kinds of things like that. So we've seen a need for that, and we've seen databases evolve that are good at doing that. Right? So that's interesting, and I think that'll continue to happen. By the way, 5G is part of that, isn't it? Giving us the speed where we can work remotely with that type of data, right, without being bogged down. So that's going to even drive the demand even further because everyone's going to be expecting databases to have these things and have them instantly available. We're also doing a lot more analysis and processing in the past. You may have heard the term data analytics various times in this course and elsewhere. We're analyzing data like never before because we have big data like never before, right? And we can get in there and find information. We're going to talk more about big data later in the course, but we can find out things that we never could have figured out in the past, right? So one example I'll tell you now, we'll talk about later in the course. By using big data, all the data collected from a person's cell phone over time, researchers have been able to predict, just by looking at people's cell phone usage, when they're going to have a depressive episode, when they're going to be depressed. And they can predict it 2 days ahead of time before the person even knows they're depressed. And that's because they're using all of this data from the past about the person. They're analyzing it in new and interesting ways, doing some really powerful processing, and they're able to figure out that, boy, Rob's going to feel depressed next week. Isn't that interesting, right? So you wouldn't think about that when you're using your phone all the time, but you're leaving all that data out there, and people can figure that out. All right. And then we've got all these new databases now that have come out that are great at handling that big data. So they're, sort of big data. They keep it safe. That's another big one now, of course. Now, you only go every couple days in the news. You don't have to wait long. There'll be another big hacking episode, won't there? So there's a lot of demands on new database applications now to kind of be bulletproof that way, where hackers aren't going to be able to get in and steal all your banking information. All right, so lots of interesting and fun things going on in the world of databases. Goes a lot further than just Microsoft Access. That's it for now, kind of the introduction to databases and content. In the next video, I'm going to go into database design in more depth. That could be a review for some of you, or it'll be new for others. But that's going to lead us into our first exercise for this week. So I'll see you there.